Procurement and supply chains are entering a completely new era. For decades, supply chain operations focused mainly on efficiency, reducing costs, improving delivery times, and managing supplier relationships. But today, a new wave of technologies is transforming how supply chains operates. Technologies like 5G connectivity, artificial intelligence, and Industrial 4.0 systems are turning traditional supply chains into intelligent, connected, and highly automated networks. Instead of reacting to problems after they happen, organizations can now predict disruptions, monitor operations in real time, and make faster decisions using data. In this video, we will explore how 5G, AI, and Industrial 4.0 are reshaping procurement and supply chain operations, and what this transformation means for professionals working in this field. Here is how we'll break this down. First, we'll look at how 5G is transforming supply chains by enabling real-time connectivity. Then, we'll explore how AI is reinventing procurement from supply risk monitoring to predictive spend insights. Next, we'll look at Industrial 4.0, the digital backbone that connects machines, data, and operations. We will also walk through the evolution towards Procurement 4.0. And finally, let's see what happens when 5G, AI, and Industrial 4.0 work together to create intelligent supply chains. Let's start with 5G, the connectivity foundation for modern digital supply chains. Compared to 4G, 5G delivers four critical capabilities. These capabilities enable real-time visibility and automation across supply chain operations. Let's see how this works. To understand why 5G matters, let's compare it with 4G. There are four key differences. First is speed. 5G can reach speeds up to 10 to 20 times faster than 4G, allowing massive amounts of operational data to move instantly. Second is real-world bandwidth, which means data-heavy applications like video analytics and IoT monitoring can run smoothly. Third is latency, or response time. 5G reduced this from around 30 to 50 milliseconds to under 10 milliseconds, enabling real-time control of robots and automated systems. And finally, connection density. 5G can support over 1 million devices per square kilometer, which makes large-scale IoT deployments possible in factories, warehouses, and logistic hubs. Together, these capabilities enable highly connected and real-time supply chain operations. 5G is not just a telecom upgrade. It is already enabling real operational changes across supply chains. On this slide, you can see several real-world applications from smart warehouse to autonomous robots to predictive maintenance and smart logistic parks. In the next few slides, I will briefly walk through these examples to show how companies are already using 5G to transform operations in manufacturing, logistics, and ports. One powerful application of 5G is live inventory tracking in smart warehouse. With 5G's high bandwidth, IoT sensors and connected devices can continuously stream real-time data on stock levels, product location, and even product condition. This gives companies instant visibility across warehouse operations, helping them to avoid stockouts, reduce overstocking, and respond faster to demand changes. Another powerful example comes from BMW factory. This facility operates over 1,000 robots and autonomous vehicles, all connected through a private 5G network. The ultra-low latency of 5G allows machines to communicate and coordinate in real time, enabling highly automated and efficient production. This is setting new benchmarks for AI-driven smart factories and low-carbon manufacturing. Autonomous robots like AGVs and AMRs rely heavily on stable connectivity. Traditional wireless networks often struggle in dense industrial environments, causing delays or disruptions. Private 5G networks solve this problem by providing ultra-low latency for real-time control, stronger coverage across large facilities, and enhanced security for mission-critical operations. This allows robots to move and coordinate more precisely and safely within factories and warehouses. Another important application is predictive maintenance. At Bosch smart factories, 5G connects production equipment so machines can continuously stream data such as vibration, temperature, and usage patterns. AI systems analyze this data to detect early signs of equipment failure before breakdowns occur. This allows maintenance to be scheduled proactively, reducing downtime, lowering costs, and ensuring smoother operations. A good logistic example comes from JD.com, 5G powered smart logistic park in Beijing. Using 5G connectivity, the facility can guide incoming trucks to the right parking space or docking bay in real time. The system also monitors loading and unloading activities across the warehouse. This improves operational efficiency, reduces waiting time for trucks, and even helps lower fuel consumption and emissions. Ports are also using 5G to improve global logistics visibility. At the Port of Rotterdam, pilot projects combine 5G, IoT sensors, and blockchain to track containers in real time. Sensors continuously transmit data such as location, temperature, and humidity during shipment. This improves transparency, reduces paperwork, and speeds up processes like customs inspections and cargo handling. 5G is also improving how people work in modern factories. At Ford's UK facility, a private 5G network connects robotic welding systems, smart tools, and wearable devices used by workers. This allows machine and staff to share data in real time, improving operational precision, safety, and diagnostics. It is a good example of how 5G helps bridge the physical and digital worlds in manufacturing. So far, we have looked at 5G, the connectivity layer enabling real-time operations across supply chains. Now, let's shift to artificial intelligence, which acts as the intelligence layer behind digital procurement. Interestingly, a Gartner survey shows that only about 10% of CEOs say their organizations are using AI strategically, and only 9% of technology leaders have a clearly defined AI vision. This shows that while AI has enormous potential, many organizations are still at an early stage of adoption. Let's explore how AI is beginning to transform procurement. AI is transforming procurement in several key ways. First, real-time supply risk monitoring, where AI analyzes signals such as supply performance, geopolitical risks, and financial indicators to detect potential disruptions early. Second, intelligent supply assessment, where AI evaluates large amounts of supply data to create more objective supplier scorecards. Third, predictive spend management, using historical purchasing data and market trends to forecast future procurement spending. Fourth, automated contract management, where AI extracts key contract terms, tracks renewal deadlines, and identifies compliance risks. Finally, strategic category management, where AI analyzes patterns across suppliers and markets to support better sourcing strategies. AI is not just theoretical. Many leading companies are already seeing real results. For example, Amazon improved order fulfillment accuracy from about 80% to 90% using advanced analytics and AI-driven decision systems. Toyota integrates IoT and AI across its supply chain to reduce downtime and improve operational efficiency. And Walmart used IoT and real-time analytics to optimize inventory levels, improve demand forecasting, and reduce stockouts. These examples show how AI is already delivering tangible operational improvements at scale. So far, we have looked at 5G as the connectivity layer and AI as the intelligence layer. Now, let's look at Industry 4.0, which brings these technologies together into a connected digital ecosystem. Industry 4.0 represents the fourth industrial revolution, where digital technologies integrate with physical operations to create smarter, more autonomous systems. It's not just one technology, but the integration of multiple technologies working together to bridge the physical and digital worlds. This diagram shows the Industry 4.0 ecosystem. At its core, Industry 4.0 connects physical operations such as machines, factories, and logistics systems with digital technologies like AI, cloud computing, big data, and IoT sensors. Together, these technologies create cyber-physical systems where machines, data, and analytics continuously interact to optimize operations. In the next slides, we'll look at 9 core technologies that form the foundation of Industry 4.0. Industry 4.0 is powered by several key technologies working together. First is the Industrial Internet of Things, or IIoT. Sensors placed on machines and products continuously collect real-time data on location, condition, and performance. Second is artificial intelligence and machine learning, which analyze this data to generate predictive insights and support automated decision making. Third is big data and analytics, which process large and complex data sets from operations, markets, and external signals to optimize supply chain performance. And finally, cloud computing, which provides the computing power and storage needed to connect systems and coordinate operation across the entire digital ecosystem. Building on the previous technologies, several additional capabilities complete the Industrial 4.0 ecosystem. 5G connectivity provides the high-speed, low-latency communication needed for real-time data exchange across thousands of connected devices. Digital twins create virtual models of physical assets or processes, allowing companies to stimulate scenarios and optimize performance. Robotics and automation introduce autonomous and collaborative robots that handle complex or repetitive tasks alongside human workers. Additive manufacturing or 3D printing enables on-demand production and mass customization. And finally, edge computing processes data closer to where it is generated, enabling faster response for real-time operational decisions. Now, let's look at how procurement itself has evolved. Over time, the procurement function has moved from a clerical, back-office activity to a strategic, technology-driven role that directly influences business performance. This transformation is often described as a Procurement 4.0 journey, which reflects the broader industrial revolutions. In the next slide, we'll look at how procurement has evolved through 4 distinct stages. Procurement has evolved significantly over time. In Procurement 1.0, the focus was mainly tactical, managing purchase, running RFQ, and reducing costs. In Procurement 2.0, the role expanded to create broader business value through category management and stronger supplier relationships. Then, in Procurement 3.0, procurement became more integrated with the enterprise, using digital systems and external data to optimize the supplier ecosystem. Today, we are entering Procurement 4.0, where technologies like AI, IoT, and big data enable real-time visibility, predictive insights, and more autonomous operations. This shifts procurement from a transactional role to a strategic driver of business performance. When 5G, AI, and Industry 4.0 come together, they create what many experts call a technology trifecta. Each technology plays a different role. 5G provides the connectivity backbone, enabling fast, real-time data flow. AI acts as the intelligence layer, analyzing data and generating predictive insights. And Industry 4.0 provides the operational framework, using technologies like IoT sensors and robotics to turn insights into real-world action. Together, they move organizations from simple automation to true autonomy. To understand how this synergy works, we can think of it in 3 layers. First, 5G acts as a connectivity backbone, moving massive amounts of data from thousands of connected devices with extremely low latency. Second, AI acts as the decision-making brain, analyzing this data to detect anomalies, predict demand, and support automated decision-making. And third, Industrial 4.0 provides the operational ecosystem, integrating technologies like digital twins, IoT sensors, and autonomous robots to turn insights into real-world actions. Together, these layers enable supply chains to move from data collections to intelligent, autonomous operations. First is operational resilience. Organizations can respond faster to disruptions by rerouting shipments or adjusting production based on real-time data. Second is predictive maintenance. IoT sensors combined with AI can detect early equipment issues, reducing unplanned downtime by up to 70% and extending asset lifespan. Third is mass customization. With technologies like digital twins and 3D printing, manufacturers can produce highly customized products efficiently, even at scale. Looking ahead, many experts believe that by 2025 to 2030, this technology synergy will become the new standard for modern supply chains. While these technologies offer enormous potential, digital transformation is not without challenges. Organizations must address issues such as infrastructure investment, legacy system integration, cybersecurity risks, and workforce skills gaps. Understanding these barriers is essential to ensure a successful and sustainable transformation. There are several practical challenges organizations must address during digital transformation. First, infrastructure costs, since technologies like 5G and Industry 4.0 upgrades require significant investment. Second, legacy system integration, where existing ERP, WMS, or TMS platforms may not easily connect with new digital technologies. Third, cybersecurity risk, as more connected devices increase the potential attack surface. Organizations must also address skills gaps, ensuring supply chain professionals develop data and AI capabilities. And finally, data quality and change resistance. Since AI systems depend on clean data, and many organizations are still hesitant to fully embrace digitalization. To summarize, procurement and supply chains are entering a new digital era. First, we are seeing the rise of agentic AI, where AI systems move beyond analytics to support autonomous decision making. Second, 5G provides the connectivity backbone, enabling real time data exchange across supply chain operations. Third, Industry 4.0 integrates the physical and digital worlds through technologies such as IoT, digital twins, and robotics. And finally, the journey towards Procurement 4.0 often begins with practical steps, implementing no regret AI solutions that deliver immediate value while building digital capabilities over time. As supply chain professionals, many of us are asking the same question: what is AI and how can it help us to do our job better? That question is exactly what inspired me to create this video. I hope you have found it useful. If you have any questions, thoughts, or real world examples, please share them in the comments. Let's learn from each other. That's all for now. Stay tuned for the next video. Bye!